So in this paper, I want to talk about how data and management practices help boost the return of from artificial intelligence investment. Okay? So it's not new to this audience that AI has been advancing rapidly and is outperforming human beings in many domains. And it seems like it's transforming business and society at the moment. So we see this AI can do the generating content in text, images, and videos. It also helps science development in terms of unfolding the structure of proteins. And in this earlier event, AI actually defeated human in Go game for the first time. It's actually in 2016. So firms are investing in AI way before this release of ChatGPT. Okay. However, this empirical evidence that AI has contributed to productivity growth and value creation has been limited. And the productivity growth has declined by half, and the real income has been stagnated for in the past decade. And most of the AI projects actually fail in the organization. This is also in line with the research Luca just presented. Okay. Although most of the corporate leaders and researchers, they claim that we're not even seeing the wall yet, but there has some doubts that AI might be hitting a wall to some extent. There's a recent New York Times article that actually demonstrating that. Well, we still see that a lot of firms that invest in AI are very, very successful. So it looks like there's a paradox. There's some explanations to this paradox. First, the false hope that AI is not as good as we thought, which doesn't seem to be the case. And the second experiment is this, the output statistics are not accounted for intangibles. If you cannot put a price on something, then you cannot count it in the outputs. The adoption of AI, the adoption curve might be steep and it's hard to learn. And the benefits of artificial intelligence might be following this J curve, this productivity J curve, which means that there are implementation lags. So in this paper, I want to focus on the heterogeneity across firms. So why do some firms invest in AI and being very successful, and some firms do not or do not invest in AI well? So what I'm finding is that the adoption as well as the impacts of AI on firm returns, they're concentrated to a distinctive set of companies. And I also find this implementation lags. And the second is that access to complementary practices such as data and management, they are critical for AI to be successful in organizations. Okay? So just a bit of literature is basically a summary of the work by people sitting in this room and I guess the other room as well. Just a preview of the results. The average effects of AI investment on productivity and market valuation appears to be noisy, so they're either small or insignificant. And of course, first, AI, it takes time for AI to be effective, and the second, there might be endogeneity issues. It could be bias from reverse causality and omitted variables. Okay? Then I construct the data. And to address this identification issue, I use this long differences approach and instrumental variable approach, which I will talk about later. And then lastly, these complementary factors, they're critical for AI success. So AI investment is only boosting productivity and market valuation when the complementary practices are intensive, and also this effect is persistent over time. So we do see this long-run performance gap. Okay, so how do I measure AI investment? So I follow this recent literature to calculate the investment in artificial intelligence as simply the ratio of the number of job postings requesting AI skills divided by total number of job postings. So I take the data from Lightcast or Burning Glass Technologies data. The name has changed a couple of times for this database. And so I use this measure because, well, AI exercises require skilled human capital input. And the skill classification in Lightcast is kind of consistent and quite reliable. And I use the intensity of this skill demand to proxy these AI investment. Okay? And then map this to CompuStat using a name address function matching. Okay. So the empirical approach is quite straightforward. So I request AI investment on a set of firm outcomes, including sales, total factor productivity, token skill, and market valuation. With a bunch of controls. So I control for firm six facts. There are some concerns of using this Lightcast job demand data because not every posting is filled. There might be separations, and also firms might be posting jobs strategically. I need 10 jobs, maybe I'll post 15 postings. Okay, so the firms that are doing that consistently over time, firm fixed specs might absorb some of that, and also include year fixed specs to absorb the aggregate supply and demand shock. Okay, so the results showed up in here. The effects of AI investment is somewhat positive, but magnitude is very small, and on productivity, it's not really different from zero. So as I said, there might be endogeneity issues. First, the reverse causality. The better performer, they tend to invest more. So this is from the demand side. And maybe the worst performer, they want to catch up. They have FOMO, right? They want to invest in AI more as well. So I really think it's an empirical question which direction it goes. And omitted variable, this unobserved shock that shifts or serially correlates with AI and outcome variables that might be impacting this result. Okay, so some explanations. The adjustment takes time, and there's only a small group of them actually benefiting from artificial intelligence, and the omitted variable on complementary factors that are actually distinguishing those companies. Okay, so I do a long difference. Long difference is take the baseline regression and take the difference from 1, 2, 3, 4, 5 years. I'm going to skip this slide. So the results are on this slide. The x-axis is just year differences horizon, and y-axis they are the performance measures. And each circle is the estimate and the confidence interval. So we do see a little bit of productivity J-curve in this TFP. Outcomes in market valuation, not so much. So it just goes straight up. Okay. Then I construct a instrumental variable. So the idea of that is to take the ex-ante AI exposure and interact that with the ease of accessing data. This is similar to this Lin's paper on robots and this finance paper by Tanya et al., Babina et al. So this ex-ante exposure, so I take this measure from Manov's paper to calculate the ex-ante industry level exposure before AI really took up. And the ease of accessing data, I take this idea from Kristina's paper, where I use the share of data service industry at the state year level so that I get some time series measure as well. Okay, so for the sake of time, I'm going to skip these slides. Okay, IV results. So strong first stage, large assets, large estimates, and so it tells that the benefits of AI is only salient in a subgroup of firms. Those are very sensitive to the construct of this instrumental variable. And it actually reflects the return to the aggregate of the direct AI investment and indirect complementary investment as well. So we know this iceberg analogy that what's actually above the water is the AI investment, and this below the water is all the complements that are not easily seen to others. Okay, now to the complements. So I measure data and management practices mostly in two ways. One is to do some text analysis from 10K reports, and second is to use this perpetual inventory of the accumulation of skills of both data and managerial talents. And then I do this complementarity test. So I do two tests. The first is this correlation test. So if they're complement, they tend to cluster, so they should be highly correlated. And second is this performance gain test, which means that the combined effect is larger than the individual effects combined. Okay, I'm going to show the results in pictures. The first is a correlation test. Data, management, and AI. Each dot is a firm year, a cluster of firm year observations. Okay, so they are highly correlated on both AI data and AI management. Second, this performance test. So I split the sample into low versus high data practices, and this is the Binz-Reg result. Again, each circle is a cluster of firm year, and if data practices is low, then in productivity and Tobin skill, we actually see that it's leading to a negative impact of AI investment, and so this miscoordination could lead to these results for data. Okay, and for management, similar story. This miscoordination could lead to no impact of AI investment. Okay, so I'll skip this marginal effect. Okay, and the last finding is that this actually persists over time. So not all firms would actually catch up, and if the company is actually intensive in these complementarities, their performance gap actually maintained for many years. For example, if you are low data complements, your performance is actually quite flat from 1, 2, 3, 4, 5 years in terms of horizon, and if you're high in that, it's actually growing, and the gap keeps widening up. Okay, so I think I'm out of time, so I will stop here and take questions. Thank you.
I guess, what are the implications of everything that you just walked through? Like, how would you advise a company to take action or not take action based on this?
So what I wrote here in this last bullet point, so they should probably think about what complementary factors they have and what they should invest. It's not like I'm going to plug in ChatGPT and everything is going to work, or I'm going to invest in AI. I'm going to hire some machine learning engineers and things going to work out. So it's probably not going to be like that. You really need to invest in a set of complementary factors and practices to really boost the performance of AI investment.
Have you looked into what those complementary factors are?
So I say again.
Have you looked into what those complementary factors are?
Data and management. It's like
yes. How are you defining AI for the purposes of this experiment? Is it just, are you looking at any job posting that mentions AI?
Right. So there are many ways. So I'm using job postings data, so it's more of like the demand side of AI, and there are many ways that people come up with a list of how they classify AI in the 16,000 different skills in Lightcast data. And my measure kind of robust to different ways of classification, how you actually take that and measure it. And for the results here, I simply take the job postings divided by total number of job postings. The postings requesting AI over the total number of job postings.
The job in the definition of your data management, data practices, right? I think they themselves, that itself would actually drive the job postings in AI, isn't it? Would you expect companies would not, without the data practices in place, posting for AI jobs?
Actually, yes. From the data, there's some, if they're low, they still have some AI job postings. Actually, from the data, they're actually doing that.
How do you measure? Sorry,
Okay, go on. Yeah.
Just a quick question. How do you measure the high or low? Who categorize that?
Categorize.
Yeah, this is high. You have a high management practice, and this company has a low management practice, and that practice does change over the time instead of maintaining at the same level over 5 years. I would assume.
That's right. So it does change. So it's a panel data, and so the way that I measure management is that I use the accumulated IT managers, so computer and information system managers within the company. So you use this inventory, perpetual inventory method with a separation and job filling rate.
Okay, thank you very much.
Offline, I'm Kristina McElheran. I am from the University of Toronto. This is joint work with Eric Brynjolfsson and MJ Yang, who is at Oklahoma, and Zachary Croft at the Census Bureau. So we did a little bit of a bait and switch with the program. I'm not the only one to do that. The title remains the same, but what I'm going to mostly focus on today is really hot off the presses, brand new findings, rather than some of the stuff that has been kicking around for a while, but I'm happy to talk about the stuff that's been kicking around as well. I have to put my disclaimer that nothing proprietary is going to be shown in the stuff that I'm going to show you that we pried out of census like 2.5 weeks ago. So this is really, really still in digestion stage, and I'm super interested in your thoughts and feelings, big feelings. There might be some big feelings about this today because I think some of what I'm going to show you will not land great with everybody, especially after Ethan's very terrifying keynote. So the first question I'm not going to do any setup because I feel like everyone who's been here and we're here in compliments has a sense that we're trying to deploy this in firms. This is moving very quickly. How do we get this done? It's very uneven. Frank has some nice results on that. We're going to dig into that as well. What can we say about sort of more recent levels of AI adoption? Why are we focusing on more recent is because we have this big project that Frank was a part of that just got published where we looked at AI adoption across the United States. We're not exaggerating here. This was 850,000 firms in our sample. And we got some really great but very low early baseline adoption rates in like the single digits. If we employment weight, it maybe got up to 18% adoption if you squint. And so everyone was like, oh, okay, that seems really low. And of course, things have really changed. And I'm going to be here to tell you that if they're changing, they're not changing that fast in these firms. We're going to zone in very much on manufacturing in this study I'm going to show you today. And we're going to look at how can we disentangle this from good old-fashioned digitization and analytics. There has been a bunch of digitization and other tools diffusing through these firms for a long time, and that's going to matter, and I'm going to show you evidence that it matters. We're going to actually ask about the barriers to adoption so we can understand a little bit about where the frictions lie and what are the micro-level productivity impacts. So what are we going to do? We are, in this study, updating the Management and Organizational Practices Survey from 2021. Anyone who's been following what Eric and I have been doing for a little bit of time here with the Census Bureau is using this survey that goes out in the manufacturing sector to better understand the availability and use of data and data-related practices, the use of predictive analytics. We actually completely overhauled it for the study. So some of what you're going to see you've never seen before, not even the questions. We're going to link this to the U.S. Census Bureau microdata at the establishment level. This gives us a really nice context in which to study productivity, which is not easy to do. We're going to deepen visibility to digitization and IT use, including cloud computing, which is another thing I'm happy to talk about. And we're going to disentangle the use of descriptive analytics, just basic dashboards and time trends, and maybe even interactive dashboards if we're getting fancy, from predictive analytics, which you might want to think of as sort of, old school prediction, where it's still got some algorithms in it, but this is not like the cognitive technologies, the self-learning, self-adaptive models. Those are separate. We pick those up in a couple of types of questions where we really triangulate on the use of AI in production. I will not have time to get into this measure. We can fight over how we measure it if you like, but rest assured this was not just me and Eric messing around with some surveys. This had to go through a lot of cognitive testing, approval of the Office of Management and Budget, in order to put this in front of respondents who told us that they had a sense of understanding what we were asking. And we're going to look at some specific technologies and use cases here. We're going to learn a bit about barriers to AI use, and we look at this is a big sample. It's a representative sample. We're going to population weight to get some sense of diffusion. I'm going to zip by that really fast. I'm going to zip even faster through the correlates of AI use and try to spend what little time I have talking about the productivity implications, both in sort of an OLS and an instrumental variables framework where we're trying to get at causality. Okay, so the first thing we have to do to make headway here is measurement. And I don't have time to tell you all the things we did to get into the measures. But what I want to flag for you is that, when we have these S-curves, anyone who studied digitization, we've got the S-curve, right? And these curves come through, and if you teach tech strategy, you talk a lot about when you switch S-curves. But firms very rarely, ditch everything they had before. And so to have data and data analytics has turned out to be really important. Eric and I talk about that in our Rapid Rise paper, and we have this data and action paper that's getting refurbished as well. We moved with the times into predictive analytics and saw that take off, and now we're looking at AI. And I think we need to stop and say, what is it we're measuring if we just ask about AI? How do we get to AI? What else is going on in the firms? And, does it matter what else is going on? And spoiler alert, it matters. And I'm going to show you a little bit about that. All right, so the MOPS 2021 is this cool thing that we've gotten to be a part of now for a while. It's a Census Bureau establishment level survey, so we have within firm variation. It's 10%. It goes to 10% of all plants in the U.S. manufacturing sector, but it overweights large plants, so we have 70% of the sector in the certainty sample. The response rate is 68%. Anyone who runs surveys knows that is an enviable number, to be sure. And this is the third wave. So this is the 2021 version of something that we've done a couple times before. You'll notice we were trying to miss COVID. I don't know how much we did, but that was why we're off cycle by a year. When I show you the adoption rates, you're going to be like, oh, dang, that seems really low. For sure, those numbers aren't right anymore. And I'm going to tell you they just did another census survey at the end of 2023, beginning of this year, showing the adoption rates have not moved much. So whatever, we think is happening in the, ChatGPT world at the individual worker level and the knowledge worker level, this is not what's going on in manufacturing in terms of using AI in production. All right, so this is actually using it to make your output and manage your supply chain and do a lot of mission critical stuff in a non-knowledge work setting. So check some of your priors about what you are doing at your comfy desk, mucking around with ChatGPT. This is production level AI use in manufacturing. The punchline is the adoption is low, skewed, and slow. It is also not the main point of what I want to show you today. Because even if you disagree with how we're measuring this, you've got to tell a story about how there is no signal in this data to show you what I'm about to show you, because some of the precision we've got here is reasonably good. All right, so what do we find just at the adoption level? So Frank was just talking about data. Thank you, Frank, for teeing up some ideas for me. This is a highly digitized sector. People forget how advanced U.S. manufacturing is, how teched up it is, how it generates more data than very data-intensive sectors of the service economy. 91% of these firms have a lot of available digitized information. Descriptive statistics is very much alive and kicking in the sector. 73% weighted report that they use it. Predictive analytics, which you might think of as a precursor to AI, as we talk about it now, that's in place on a weighted basis. But you'll see I graded out. I wasn't going to talk about it because of time and I have to keep moving, but we also can see how intensively they're using it. And so when I report these extensive margin adoption metrics, recognize that how much of the production relies on this technology is lagging even more. All right, so y'all wanted to know about AI. So if we look at the most generous way we can measure this, so any use of a machine-based system that can perceive and learn about its environment and then make relevant predictions, recommendations, or decisions for an objective that is determined by humans. If you leave this out, the plant managers are like, yeah, no, we don't do that here. There's very much humans in the loop in these systems. And specific technologies like machine vision, speech recognition, predictive maintenance, a leading use case, and AI-enabled robots and automated guided vehicles. You put this all together, and we're still at a very low extensive margin of adoption. All right, that's going to matter because what I'm going to show you, you're going to want to interpret that in terms of moving the needle into really intensive AI use is not really prevalent in this data. So this is across the 30,000 plants. All right, the key barriers to adoption. The leading one is cost. So when you talk to them about why aren't they doing it or why have they been slow, cost is the first one that they mention. The other one is no use case here. They haven't quite done the process innovation. They haven't done the redesign necessary to really make this make sense. And the other is whether there's a level of AI expertise or skills at this establishment. So this is saying if we don't do AI, it's because we have an AI-specific skills gap here. Now, firms are able to adopt AI in spite of this, and we actually instrument for AI use by taking the reverse of this measure. And in the next 2 minutes, I won't be able to fight with you about the IV, which is everybody's favorite thing to do when I present this table, but that's what the break is for, right? Okay, so we have a lot of other variables. Mostly what I'm going to show you is our DV on value added. That's going to be outputs minus inputs. I'm not going to be able to show you any fixed effects because we have this one cross section, but we're going to control for a lot of stuff. All right, so why am I showing you presence with very little time? The first is to show that when we look at the probability of AI use, or if we put the AI use index on the left-hand side, you'll see description looks like it substitutes for AI. So not only is descriptive statistics still alive and kicking, but it actually may be getting in the way, whereas having done predictive analytics seems to ease this. And in the complements, so this is just to say our first stage works with the skills gap. And in a little section on complements here, I just wanted to point out that we have some information on the management practices. And we show that super structured management practices with very little slack, Arvin isn't in the room, is really problematic for this adoption. So we're seeing the management practices affect adoption. All right, so what happens for performance? If you ignore the data, we can find a positive correlation between AI use and productivity. But as soon as we account for other technologies, this drops by a lot. You control for size, by positive effect. You add a little capital, it turns negative, and then you instrument for it, and it's really big and negative. So we're seeing adjustment costs in this early diffusion of AI in manufacturing. We're able to show that this is correlated with, it's actually instrumented here, so you could probably interpret it as causal, more inventories, which firms use to buffer, more robots, and lower employment. So we're seeing a lot of changes in the firms that do this. This is early days. We don't get to see change over time. But we do think that we're seeing these adjustment costs for these relatively early adopters, and that these management practices, these complements matter for adoption and probably for performance. And I don't have time to tell you too much about the conclusions or the limitations. It's not perfect, but I'm happy to talk about it. And here's the other work if you want to follow up.
Great. All right. So the previous two speakers were talking about the longer time horizon of AI over the last 5 to 10 years or so. We're going to be focusing much more concretely on generative AI and the promise that it has for firms and workers in particular. And so we're trying to quantify what exactly the impact is of generative AI on firms and what we can currently already see in the data. There's two things to distinguish here. There's, on the one hand, generative AI as a general purpose technology, a technology that makes all white-collar workers more productive to some degree, and as a result, it's going to impact a large number of firms across different industries, and that raises lots of questions around which firms are going to be more impacted, and does it matter if it's a substitute or a complement for labor? How is this going to matter for workers? It's important to distinguish that from this more, oftentimes more newsy element of generative AI, where it's going to impact particular firms that are selling AI-related products, and who've seen their stock prices respond very strongly to different news around this technology. But we're in our study more focused on this broader economic impact, not on these particular firms contributing to the technology. We try to solve three different challenges. On the one hand, measuring the impact of a technology on the economy is generally hard because technologies tend to unfold over long time horizons. With generative AI, we have this really nice lab where this technology becomes well known with the release of ChatGPT and almost instantly takes the world by storm. And so it allows us to get a really nice shock to see what firms are predicted to benefit from it. We try to make some progress on figuring out whether or not it substitutes or complements different workers and where we're more likely to see positive or negative impacts on different workers. And we're trying to figure out how this impacts firms rather than just occupations or individual tasks. The way we get a measure of exposure to generative AI is that we go from tasks, map them into occupations, and then map those occupations into firms. For mapping the tasks, we follow the methodology that Daniel Rock and co-authors developed for basically having a large language model score individual tasks against a rubric of the kind of stuff that generative AI can help you with, and then taking those tasks that can be made more productive using generative AI and checking which occupations are doing those tasks. And so for each occupation, you end up with some share of their tasks that can be made more productive. The most exposed occupations are things like telemarketers and proofreaders. The least exposed occupations, just a subsample of them, are lots of manual occupations, tire builders, tailors, things like that. And in general, it's higher wage occupations that tend to be more impacted. But other papers have shown this so far. What we're doing is we're then taking that information and scaling it up to the firm level by taking firms' occupation structures. So we look at firms' employment on LinkedIn and figure out what kinds of occupations they tend to be employing and use that to figure out which firms are more likely to have these kinds of tasks that you can make more productive. Right at the top, if you rank these firms, you find firms like IBM, Intuit, Qualcomm, Microsoft down here, a lot of sort of firms that are in different sectors but have a lot of technology going on, or administrative services of some kind. This is actually nice. The first time we released this working paper, basically the week after IBM came out with this news item where they said they're going to pause hiring on thousands of jobs because generative AI might make them more productive. So that was a nice validation for this table. At the bottom of the large firms, you see a lot of firms that are working in transportation or services where there's a lot of manual labor that's not going to be impacted by this kind of technology. All right, so what does this exposure do to these firms? We try to figure out what the impact is using market reactions to the release of ChatGPT for different firms. Just to check that people are actually paying attention. If you're looking at the Twitter mentions of ChatGPT right after ChatGPT is released here on November 31st of 2022, you find that you find this massive spike in people just talking about this technology. So you have this really unusually large reaction immediately after the technology is released. And firms are aware of this. So if you look at whether or not firms are talking about this technology in their earnings calls, we collected some data on earnings calls, just check whether or not they mention large language models or generative AI. Firms immediately start talking about this in the first quarter of 2023. So firms are aware that these technologies exist and that they can make use of them. And then the first thing we tested was to see whether or not our measure of exposures, our sort of bottom-up labor measure of how much your firm might benefit from this technology, whether or not it predicts that your firm talks more about it. So all the firms start talking more about it. Do the firms that we're predicting that benefit more, do they get an even bigger boost in terms of communicating to their investors about this? And that's exactly what we find. Being more exposed to generative AI has no impact before generative AI sort of becomes a big deal. Right afterwards, the firms that have more exposure also start talking more about it, even relative to this general uptick in attention to the technology. And then we test the impact on stock prices by forming a portfolio that goes long stocks that are really highly exposed to this technology, so that have a big productivity boost that we can expect from this, and short stocks that have low exposure to the technology, so where we wouldn't see a big impact. And we call this the artificial minus human portfolio. So you're sort of investing in the promise of the technology. And we find that this stock portfolio would have returned around 0.4% daily during the 2 weeks after ChatGPT was released. So there was big stock market outperformance for the stocks that are most likely to benefit from this technology. And that outperformance is concentrated in this particular event period. So these aren't stocks that generally outperform. These are stocks that outperformed right after ChatGPT was released. So this is easy to see in a graph. So in green are the stocks that are not exposed to the technology. In orange are the stocks that are most exposed to the technology, and then in blue is the difference between them. So the returns on a portfolio that goes long one and short the other. And you can see that right when ChatGPT is released, you see this big divergence where the stocks that are more exposed have much higher returns in the subsequent period, and that gap then persists over time. You see another little uptick here, which we didn't study explicitly, but that's around the time that GPT-4 then is released. All right, this is quite robust to lots of different controls. One thing you might be worried about is the thing I mentioned earlier, that some firms are directly contributing to AI products here, right? They're developing the product, they're selling cloud computing software, whatever it is, and a lot of those firms have programmers, and programmers are an important occupation here that's also going to be impacted in its productivity. And so maybe these are just the same firms. Maybe these are firms selling AI products, and we're also finding that they have productivity potential, and that might confound this. So we tried to come up with different measures of product market exposure, how much you're selling into this boom to some degree, so to make sure that we're really identifying the productivity side here, not the revenue side. And so we went through 10Ks and tried to figure out whether or not they talk about artificial intelligence in their business model, whether or not they mentioned, this should say AI here, whether or not they just mentioned the word AI many times. We looked at Goldman Sachs' list of near-term beneficiaries of AIs and used that sort of as a calibration of which firms should be likely to benefit from this. And we also used a measure of AI skill share before generative AI was released, so firms that were already exhibiting a lot of AI-related skills, because those are likely the firms that are also working on AI technologies. And it turns out that these, if you look at this cumulative abnormal return around the release of ChatGPT, it's quite robust to including all of these different controls for product market exposure. So that doesn't seem to be it. It's not that you're just selling cloud computing software and that's why your returns go up. The other thing we were interested in was wondering whether or not your firm needs particular prerequisites to be able to benefit from this. So the previous two speakers luckily already talked about this idea that there might be some sort of skill level that you need as a firm in terms of familiarity with data or just technical skill in order to make good use of this technology and really realize the value. And so there's lots of evidence that being able to handle data is an important complement to being able to use generative AI, right? You need to be able to manage data to fine-tune your models or to actually put into practice some process automation or combine your proprietary data with these analytical capabilities to really get a lot of value out of these. And so we defined two measures for data assets that a company might have in their data management capabilities. On the one hand, we let a large language model loose on a firm's annual reports, and we give it a very structured prompt to figure out if we can find any evidence in the description of the business in the annual report that it involves a lot of data, that they collect a lot of data, they worry about data security, and we sort of parse it for these morsels of evidence that tell us that this company already knows how to handle data well. And we also rely on another measure that Abbas and Feldkamp defined, which is based on this idea that one nice proxy for whether or not you have data management skills is whether or not you have a lot of data managers. And so you can check in the LinkedIn data, do these companies employ a lot of people that sound like they're data managers? And so if we see that your company has a lot of people that would be data managers, we can use that as a proxy for whether or not you're managing a lot of data. And we find that our outperformance after ChatGPT is released is concentrated in companies that have these data management skills. So it's not that all companies that have this productivity potential see their stock returns go up. It's the companies that actually would be able to put this into practice because they have some existing data capabilities. And then the last thing we're interested in was, this is all well and good for the firms, their stock returns go up. What does this mean for the workers? And so we looked at trying to disentangle this idea of does this substitute or complement for workers? And in particular, we tried to map this idea of substituting and complementing onto which particular tasks are impacted. The one nice thing that you can get from the ONET database for different tasks is that they actually classify for particular occupations whether or not a task is a core task or a supplemental task. And these kind of correspond to a core task being something that is essential to the job that you do, rather than something that you sort of incidentally landed in your bucket of stuff you do on a daily basis, but that isn't really what drives your value to the firm. And so we expected that if it's a core task that AI is impacting, that's more likely to be substituting for your job. Right? It's more likely to be something where the AI can now do the thing that really made you valuable for the firm. Whereas if it's mostly impacting your supplemental tasks, in that case, for instance, if you're a faculty member, if the AI can do my expenses for me or grade papers for me, that gives me more time to focus on research and teaching, and thereby might actually make me more valuable for the firm. And so we would expect a more positive impact if supplemental tasks are impacted, and a more negative impact from the core task being impacted of the worker. And so we look at, and so we differentiate whether or not our impact on occupations comes from these core versus supplemental tasks. What we find is, in general, if we look at the occupation level, we see that hiring tends to go down in general for jobs that are more impacted. That seems intuitive. But there's a distinction, as we would expect, between whether or not you have a high share of your exposure coming from supplemental tasks, in which case this negative impact is less negative. And the same is true for the wage impact for workers. It's overall a negative wage impact for workers, but that is mitigated if the tasks that are impacted are your supplemental tasks. We can do the same thing from the firm perspective. Do we see firms hiring fewer workers? We find that firms, yes, they do hire fewer workers of those kinds of occupations that are most impacted, but that decline in hiring is less negative if you're the kind of worker where only your supplemental tasks are impacted. So the substitution effect seems to be mitigated for workers where the AI impact comes for the tasks that are not core to what they're doing. And we see the flip side for firm profitability. Firms become more profitable if they have more of these kinds of workers where you have a productivity impact, and that justifies our stock market impact that we find, and that profitability impact is smaller if these firms have workers where only the supplemental tasks are impacted. Right. Let me see that. All right. Okay. Just to wrap up, so what we show in this paper is that this was a large technology shock that impacted firms. Stock returns went up for firms that were more exposed to these technologies, and they also saw their profitability increase, and they reduced hiring for the kinds of workers that were most likely to be impacted. And we found this important heterogeneity that you need data assets or data management skills in order to be able to actually benefit from this technology. And for workers, it's negative, but it's less negative if you're impacting your supplemental tasks rather than your core tasks. All right, thanks.
Okay, according to the schedule, okay, we have one question. Okay.
Very quick. So have you checked the heterogeneity of the firm's ROI before the
return on investments?
Right.
Yes. So we actually have firm fixed effects in there. So like that we differentiate. This is all variation within each firm.
Yes. I'm talking about moderate effects to explain this supplemental task.
No, we did not look at that. So your suggestion would be that maybe firms that have generally higher returns to investment are somehow differentially using this.
Exactly.
Okay, yeah, that's something we can look at. Thanks.